Hello, my name is Flora Huang, and I'm from Philadelphia, USA. Hello, we are Women in Data Science.
I became a WIDS ambassador because I dream of an equitable world where empowered women help humanity make better decisions through data science.
As a woman, I'm hoping more Peruvian women would be motivated to join this exciting field.
The WIDS community has really enhanced my sense of purpose in these life goals, and it has really built my confidence in such a meaningful way to be able to mentor, motivate, and support others.
The most rewarding and impactful aspect about my work as a clinical data scientist is to use the data generated by doctors, nurses, and the healthcare system to improve the care of future patients.
I'm delighted to bring this event to Pakistan, along with so many WIDS ambassadors worldwide, so that we can inspire all young girls or women to take up career in data science.
The use of data science to address climate change and sustainability issues continues to inspire me in my data science journey.
Through WIDS Alexandria, I've got the chance to meet with brilliant female professors, learn about the research, and bring that to my community as well.
I'm a WIDS ambassador because I wanted to inspire more young girls like me to join the field of data science, and I believe that in the future there must be more women in this field.
I'm really excited to continue bringing WIDS events to my school and schools across Australia to empower girls to get involved in the field.
It's great that we've got Women in Data Science events, and know that there's so many more inspiring stories as part of the Women in Data Science journey.
Hi, I'm Carolyn Bertozzi, and I am a chemist who works in the area of drug discovery. I've had many opportunities in my life to collaborate with data scientists. They've been absolutely central to the work that we do. We couldn't have made the discoveries that we've made without having people to analyze very large data sets and to help us find hidden trends within them. Now, when I was growing up, I was somewhat insulated from the idea that women or girls couldn't be scientists because I came from a family of scientists. And when I was in college, I learned that not everyone had that privilege. I hope that all of you women data scientists or aspiring data scientists will truly feel that you belong in the field, because I believe it, and your participation is absolutely essential for us to bring the full benefits of data science to solve the big problems in humanity. So just as I was so fortunate to have a family that created an environment where I could believe in myself as a scientist, I'm hoping that you all have the confidence to pursue your dreams and that you help the generation that follows you in the same way that hopefully someone of my generation can be of help to you. Good luck with all of your work.
السلام عليكم ورحمة الله وبركاته. شكرا لحضور اليوم جميعكم، وشكرا للجهود الجبارة اللي نظمت هذا المؤتمر اللي يعطينا نظرة بسيطة جدا عن قدرات نساء مملكتنا العظيمة. اليوم أنا هاجر الحافي برفقة ديما الحارث بنعطيكم ورشة عمل مكثفة عن المشين ليرنينج. We're going to go over the AI powered medical diagnosis. لكن قبل ما نبدأ بعطيكم نبذة بسيطة عن نفسي. تخرجت من جامعة الإمام عبد الرحمن بن فيصل 2020.
نعتذر بس مشاكل تقنية. تخرجت ب 2020 واليوم أنا متحمسة أنا وديما نقدم لكم a crash course in machine learning and AI powered medical diagnosis.
معكم ديما الحارث. تخرجت من جامعة الإمام عبد الرحمن بن فيصل في سنة 2020، وحاليا أنا وهاجر نعمل كمحللات نظم تنقيب في شركة أرامكو السعودية. و even though we work in the oil and gas field, we still use machine learning in our day-to-day lives. And that's the beauty of machine learning, is that you can apply it to any field and any aspect. بما فيها المedical field, which we will explore today. So without further ado, let's get right into it. So how are you going to make the most out of this session? You can follow along as we explore each session together, and I'll be doing that. So I'll be going through some theoretical parts, and then you can scan the QR code on the screen to access the Jupyter notebook, which Haj will be presenting, and keep track as we apply each phase or each section. So what's our agenda for today? First, we're going to look at what is machine learning, and every single phase of machine learning. We have data pre-processing, model selection, model training and testing, and how to fine-tune and improve this model of yours. And finally, we'll be talking about deployment and the real-world impact of your model. So what is machine learning? Machine learning is a branch of artificial intelligence and computer science, which focuses on the use of data and algorithms to imitate the way humans think and learn. And it uses this technique to gradually improve its accuracy. So whether it's recommending movies or personalizing online shopping experiences or even detecting fraudulent transactions, machine learning can do all of this and more. It can process massive amounts of data to find hidden insights and provide valuable predictions and projections from this data. So what is machine learning? There are two types of machine learning, mainly supervised and unsupervised learning. Supervised being that we know the type of problem that we're solving, we know what we're trying to predict. So we know exactly the inputs and the outputs of the data. On the other hand, you have unsupervised learning. So we don't know what the problem is that we're trying to predict. We're trying to learn insights and learn patterns from the data. So for supervised learning, we have classification and regression. Classification being when we're looking or we're trying to predict categorical variables. So such as when we're trying to predict whether an email is spam or not spam. As for regression, we're trying to predict a numerical value. So we're predicting, for example, the price of a house or the length of a certain item. For unsupervised, we have two types and many more as well. For clustering, it's mainly used for, let's say, customer segmentation when it comes to marketing. So we might try to categorize our customers into two different groups, whether they might be interested in some specific products, so we can market those products to them. As for association, usually we see this when you're shopping for items in Amazon, for example. So you buy one product and then it shows you the products that other people bought as well. So it's associating you with some other buyers since you bought the same product. So how can you summarize machine learning in a singular sentence? We usually pick this sentence. A machine learning model is only as good as the data it is fed. So in machine learning, we usually rely on data. It's all about data, data, data. We have this sentence, very famous sentence actually, garbage in equals garbage out. So if you feed your model, if you teach your model with garbage data, you will get a garbage model. So you better focus on processing your data. Actually, data pre-processing is the main and biggest stage of machine learning. It is such a crucial phase. So let's use a chef analogy. If you were a chef and you're trying to prepare a dish, you wouldn't want to use expired or spoiled ingredients. Instead, you would focus on fresh and high-quality ingredients. Likewise, in machine learning, we try to look for high-quality, clean data. So let's take a look at this data set. We have a data set containing age, gender, education, annual income, etc., to predict whether this person might be smoking or not. So we have so many different information in so many different forms. However, we have missing data as well, as you can see here, signified by the NA. So we can't really process this data because there's so many missing data. What can we do here? If we have a certain record that mostly has missing data, we'd usually just remove the record, since we can't really draw many insights from this record. If we include this record, actually, it might be confusing for the model. So in this case, we just completely eliminate the record. In another case, let's say here in the education column, we have a singular missing value. So this might be easy to predict or fill in, or what you call machine learning impute. So we can, because we have, a lot of the other columns have data, so it might be wasteful to remove this record. So instead we impute this value or replace it. And we have so many different imputation methods, the first one being mean imputation. So we replace the missing values with the average of the available data. This is usually used for numerical values since we're using the average. For columns that are categorical, instead we might use the mode imputation. So we're going to fill in this missing value by replacing it with the most commonly occurring value in the column. And finally, we have the k-nearest neighbor imputation. This method is slightly smarter because we actually fill in the missing value by taking the average of values from other similar records, allowing for more context-aware imputation. So this is going to be smarter, and this imputation or replacement will be more accurate. So for this missing value over here, we have 3 different values possible. We have secondary, bachelor's, and doctorate. So if we use K&N imputation, for example, we might look at the age column, or the algorithm might look at the age column and see that, if the age was example 19, then this person is most likely in the secondary education phase. Likewise for the second record, where it imputed the value of bachelor's, since the person is 28 years old. So that makes sense. Okay, moving on. So now after we verified the quality of ingredients, we, ingredients if we're going to cook, but the data, we make sure that the data has no missing values. Now we need to make sure that our data is in a suitable format, because computers only learn or can understand zeros and ones. So we have to make sure that our data is in a suitable format as well. Okay, so as you can see, we have a lot of information here that a computer might not understand because we have a lot of textual data. The first one being education. For this case, as you can see, this is in a hierarchy order. For example, so the first would be secondary, bachelor's, doctorate. That's the way it usually goes. Well, so for this case, we might use label encoding. So for example, 0 would be secondary, 1 would be bachelor's, and 2 would be doctorate. So this would make sense for a model. It will give higher value to the doctorate value since it is higher in the hierarchy. Okay, so for another column, let's say gender, we have male and female. We're going to use something called one-hot encoding, which is used for columns when there is no hierarchy value. We can't say that females are like higher or lower than males. So you have to use something called one-hot encoding. In this case, we're going to split this column into 2 different columns, using zeros and ones to signify whether this column applies or not. So for the first row, for example, is this person a male? No, it is not, so it's 0. Is it a female? Then yes. It's female, and we put a 1. And the same goes for the other rows. As you can see, we can rely on only one column because it doesn't make sense for us to keep both columns, because if the person is not male, then of course it's a female. So it makes sense to just use one column. Okay, same goes for smoking. We can do the same thing that we did with the gender, and then we can translate the yes into 1 and the no into zeros. Moving on into the race column. As you can see, we have 3 different values: Middle Eastern, White, African American. This one's going to be a bit tricky since it's not as simple as gender, male and female. So we're going to do the same thing, and we're going to split it into 3 different columns, again, to signify whether this thing applies or not. So the first person, is this person Middle Eastern? Yes. Are they white? No. Are they African American? No. Same thing goes for the second row as well. So as you can see, we can still apply the same concept and remove one of the columns, since if this person, for example, last one, yeah, so they're not Middle Eastern, they're not white, then it makes sense for them to be African American. So if we remove this column, then it can help us reduce the dimensionality of the data. Okay, now as you can see, all our data is in nice and clean format. It's all numerical, it's all good. So now our machine or our model can understand this data. Moving on to the training testing splits. Again, if we go back to the chef analogy, let's say you gathered all the ingredients. Most likely you want to make sure that your, whatever you cooked is good, right? So you would take 80% of your ingredients for training, or let's say cooking, and then you're going to take 20% of it to test or give out to your friends or your family, make sure whatever you cooked is nice, right? So you're going to apply the same concept to machine learning. So you'll split your data into 2 different sets, one for training and one for testing. Same goes for here. So we're going to take random samples from all of our data sets and either categorize it as for training or testing. And we're going to try to be as random as possible. And there are so many algorithms to do this that Haj will go through. and split it into 80 or 20. There are so many different splits out there depending on the kind of type of your problem. So we can either do 75-25, 70-20, but 80-20 is the industry standard, I would say. Okay, so we've learned a lot. So now you can scan the QR code as Haji goes through the notebook and goes through all the concepts I went through.
Assalamu alaikum again. So were you all able to scan the notebook?
Okay, I'll go back.
Go back to the video. Okay. Now we're going to go to our digital notebook. I'm going to go quickly over the environment that we're using here. We're using Google Cloud and we're using Jupyter Notebook. These are the environments that we can use to work on data science projects using Python or other languages. Google Cloud, as you saw before, we just all gathered or we run the same notebook using a QR code. So it allows the collaboration of teams and working in the same environment. It also you can install the libraries easily and have let's say your data in the folder that we'll show. Okay. So first, I'm going to go over this workshop. We're going to use the cancer data set from Wisconsin Hospital. This data is of the digitized images. So these images were digitized, and the values from this extracted images were used to predict if the cells are cancerous or not. Okay. So first, we're going to import our libraries here. So the most important libraries here, or the most used, are Pandas, Matplotlib used for visualization, Seaborn is used also for visualization, but also to show the correlation between the data. So after that, we're going to use or read our data from the internet. There is a good way to just import your data using GitHub, which you can read your data from a URL from the internet. You can also, using Google Cloud, to import it here or upload it or use or mount your Google Drive here. Okay, so after that, we're gonna get a glimpse at our data to see the columns that are there and see the types of data that we have. So as you can see here, when we use the head function, it will print the first 10 rows of each column. We have the ID, we have the diagnosis, which is a categorical value. We also have a mix of, let's say, float data and data in 1,000. And you can see here an important column, which is called name. This column, as you can see, it has none values, but we want to make sure that all the data in this column is empty, so we can drop it or use it in our data. So this is just a glimpse at the data. So now we're going to use this graph to see the maximum or minimum value. It's going to give us statistics about each column and the data presented there. Okay, so we can see here that the ID, or let's say the one which is unnamed, it still have none values all over, so we can just drop it. So now we understood our data, and we can see that the classes that we have present in this data is benign and malignant, which is cancerous or non-cancerous cells. Okay, and this is how many in each class of data. So we have around 350 in benign and 200 in the malignant. And this we can use the matplotlib to visualize the distribution of the data. And the perfect case in machine learning, we want a balanced data of both classes. However, in real world, this is not the case. So we will have more non-cancerous cells in real world, right? And we will have, let's say, half of that is malignant data. So we will say this is a good representation of real world. After that, we're gonna use the Seaborn library, which will give us, a clear visualization of the correlation between the data. They want you to, focus with me here on the data that has, let's say, ID. Let's see ID. It will have no correlation with any other data feature in the table. So in that case, we can see that it's not contributing to the model, so we can just drop it. As you can see, for texture mean, it has a strong correlation with other data. So that means it will contribute to the model's prediction of the cancerous or non-cancerous cells. Okay, now that we understood our data now, and we get a good understanding of our data, we can start the reprocessing. As Dima said, if the column is empty, we can just drop it. So we will drop the ID. The ID will not contribute to our model. It's of no information to our prediction of the cancerous cells, and we will drop the unnamed column. Okay. After that, we're going to impute the values, and in this case, we're going to use the strategy of mean. You remember the three methods Dima explained? We can use mean because it makes sense here for this column. The radius mean, which is an average, قدر الأفرج للورم. So to impute this column, we're going to use the mean as it will makes the most sense for this column. So based on your data, you can use different techniques. Now, at the early stages when I did machine learning, I always, when I fit my model, I get an error, which is I try to fit the model without, labeling or encoding my label. So the label should be only zeros and ones. It cannot be categorical. So that's why we use the label encoder. So now, we're gonna, split our data into the target. Our target is the diagnosis. Is it a malignant or benign? So we have X as our training data and Y is the target. Now, I want you to pay attention here as we're going to use the train test split. We're going to pass our data, the train data X, our target Y. The test size is 0.2, as this will represent your target. So 0.2 will be 20, and training will be 80. And the random state here, when you specify number, it means the seed number. So as Dima said, the model will choose the data randomly, okay? So to train the model. So to ensure that the model take the same sample each time, if you run the model, you need to specify a number. It doesn't mean anything, 42. So I can go to 100, 102, it doesn't matter. It ensures that each time I run the model, I will get the same results or the same performance. So I will have a consistent performance, okay? And then we're gonna scale our data. As we saw, our data, some of them in thousands, some of them in the zeros and ones. So to ensure that the model can get the most of the data and understand it better, we can scale it into using the standard scaler between zeros and ones. And now, Dima can continue.
So now let's look at the types of problems that we can solve using machine learning. So if we, again, go back to the chef analogy, we can see that just like a chef considers the nature of the occasion and ingredients available to choose the right recipe that they're going to make, we also need to consider factors such as the problem type and the available data that we have to choose the best algorithm for our problem. So we have so many different types of problems. Of course, this isn't all of them, but I went through the first three in the earlier slide, which is classification, regression, and clustering. The fourth one, which is an interesting one, is the anomaly detection problem. So we're trying to identify unusual instances or patterns that deviate from the normal patterns. So if you can, try to brainstorm what a problem like that would look like, it's the you would use it to detect fraudulent transactions in your bank account. So if usually during a week you spend about 1,000 riyals and then suddenly you start spending 3,000, they might say that this is a fraudulent transaction. We can actually train a machine learning model to do that for us. Another problem is the recommendation systems, which is like I said, used in Amazon or let's say Netflix. or Spotify. And the last one is the time series analysis. So we're analyzing data that is ordered in time to identify patterns, which is usually used in weather prediction. So how do you choose the right algorithm? I'm going to tackle the first two types of problems since they're the most common ones, and that is classification and regression. There are famous algorithms that are used for both problems. So for classification, we usually use logistic regression, and for regression, we might use something like linear regression. But again, there is a massive overlap between these two problems. So most commonly, you would find an algorithm that is used for both, let's say decision trees, for example. So how do you understand, or how do you know if our model is performing well? Again, there are different evaluation metrics for each problem type. So for classification, you might use something like accuracy, F1 score, precision and recall, and AFC. Of course, all of these have meaningful meanings, which I will go through, but every single one of them will give us an insight to how well our model is performing. And likewise, for regression, we might use something like mean squared error, or mean absolute error, or R-squared. These are the equivalents of, say, for example, accuracy or recall. These are just ways to tell how well our model is performing. And after we evaluate the model, or let's say you learned how to evaluate the model, we might use something such as k-fold cross-validation. Now, when you initially split your data, you might be wondering, let's say you took 20 for testing and 8% for training. You might be wondering, what if I didn't select the best, segment for training, or testing? What if I selected something, different? What if I selected another, collection of data samples? Well, you could use something such as k-fold cross-validation, where K stands for the number of folds. So you're going to repeat this process 4 times. You're going to use your entire data set once and take a section, let's say this section for testing, and that section for training. And then you're going to get the accuracy. And then the second fold, you will take a different section for testing and the remaining for training. So you're going to guarantee that when you finish the k-fold cross-validation, you can guarantee that you use every single possible segmentation for training and testing. So you can cover all the possibilities. And so you're going to get different accuracies. So to tell whether your model is generalizing well or not, you can take the average of these accuracies and get a general idea of how well your model is performing. So we call this process k-fold cross-validation. So let's say we've evaluated the model, we've done the k-fold cross-validation. Let's say the model is not performing as well as we wanted it to be. There are options. You can fine-tune and improve your model. So, and for each model you've used, such as SPM decision tree, random forest, there are specific ways to fine-tune your model. So for SPM, you might decide to optimize the kernel function. For decision tree, you might fine-tune some parameters. Same goes for random forest. You might fine-tune the number of trees. So every time you change something in your model, you might get lucky and end up improving your model. So you're gonna have to experiment a lot and try to get the best model possible. So now I'm gonna hand it over to Hajib to go through the evaluation and training of your model.
Okay, now that we transform the data and we get extract scale variable and x-test scale, we're gonna use the SVM model. So you might question, why are we using SVM for this problem? You need to search exactly what classifiers, as Dima mentioned, work best for your problem. So we're using SVM here because we have a high dimensionality of columns. Also, this problem is complex. So this problem is using images, and it's using the digitized numbers. So these numbers have, let's say, as we said, the mean radius and other data that is complex for a simpler machine learning model or algorithm. So we're going to use SVM. After that, we're going to get the k-fold cross-validation. And as you can see here, it performs well because we want to verify, as Dima said, that this model will perform well on all data folds. So as you can see here, it varies from 95 till 98. So that's good. Okay. After that, we're gonna train our model on the whole data using the SVM, and then we're gonna after fitting the model, we're gonna predict the target. And as you can see here, we scored an accuracy of 98%. So here, using the classification report function or library, we can use to get the precision, recall, F1 score of our model, and we can see all high values or scores of the SVM model on this data. Now we're going to talk about the fine-tuning of the model. And this problem, it won't, apply. You will see that it won't apply. However, what you can do to fine-tune your model, I will show. We will search what SVM parameters are. So it has the C parameter and it has the kernel parameter. Also, there are multiple parameters, but we're going to cover these for now. So what is the kernel referring to? It's the algorithm that will fit the data. So if my data is linear, or I want to use the linear function, I can just use, a simple linear function. However, for RBF or sigmoid, they are more complex function that will fit the complex data or relationship of your data set. Okay, C is let's say 0.11 and 10. It's like a score you give to see or compromise the simplicity of your model and performance. Okay, so there is a good way. I think I mentioned you can experiment with different values, but however, grid search CV library is a great one, as it will go through all the parameter grids that you provided, and it will train the model on, and it will show you the best one to choose. And as you can see here, it prints a C1 and kernel RBF, which is exactly the standard one when you call SVM function or algorithm. So as you can see here, when we fit our model and train it again on the same data set, we will have the same results as these hyperparameters are standard for SVM algorithm. And that's it for this section. Now we'll go back to the model deployment.
So after you've trained your model, let's say you have a pretty good model that's ready for deployment. So in the real life world, you're not just going to keep your model, on your PC. You most likely want to use this in production somewhere. So the first step would be to choose a proper deployment infrastructure. So this might be something like an AWS server or on Google Cloud or Azure. Next, you're going to package and deploy this model with all its dependency into a deployable format, such as a Docker container. So it contains everything that you might need to deploy this model onto the cloud or on a local server as well. So, and most importantly, you want to handle the data input and output. So you'll make sure that you have an API that will allow data to be read and to allow you to read from that model as well. So API will make sure that you can deploy this easily anywhere. You can use it on a website, on an application. This will make it very easy for you to access your model. And last but not least, you want to monitor and maintain your model. So you don't just deploy your model and forget about it. You want to make sure that you read actual real-life data and use that for training and testing as well. Make sure that you constantly improve your model. So you're going to implement monitoring mechanisms to track the model's performance and ensure security and privacy as well. That's an important aspect. And regularly maintain and update the deployed model. So if you want to quickly summarize everything that we went through, let's take a look at machine learning at a glance. So this is a continuous process of constantly improving your model. So first, it will start with fetching the data, and then you're going to clean your data, and then you're going to build and train the model, evaluate it, and once you're confident about your model, you're going to deploy it to production, and then you're going to constantly maintain and monitor this model. Once you get over and over again. So, any questions? Okay. questions? You have a question? First of all, thank you for your presentations and you make life easier. When you talk about machine learning, the real case scenario when you are working in real world problem. Just I have to add about the using pandas to extract the information and asking about your data, finding the missing values and everything. I recently came across an AI tool that's working with Panda that you can use prompt engineering. Instead of writing the traditional way that we have learned for a longer time, that give me the meme, give me the everything, and you have to write it in a coding format. There is something called Pandas and AI. It's an API library. You can import it in your Jupyter notebook, and you just need to write a prompt asking about anything of that. So it's something recently uses Pandas with generative AI, as we are in this workshop or this event is talking a lot about the LLM and the generative AI. So I think it's worth mentioning that now we have jumped from the traditional way of machine learning to the generative AI in every aspect of our lives, even of as an AI engineers working on this data. This is my comment. I have a question regarding choosing the models that fit our data. I think this is the most important problem when you are working on images or text or any kind of problems, even if it's a classification or any kind of problem. Feature engineering. If you get a bad feature, you will not get a good performance. If you get a good feature, how you could say that my model is extracting a valuable features that fit in my problem? This is the first question. The second question, even though if I have something to evaluate, am I getting a good features for my model, for my specific problem? How would you say this accuracy is good in my performance? Because we never say 100%. We never. And if we came across applications with 100%, we are, as scientists, questioning how they did get that. It's never. People usually think, but I think there is a certain of agreement from your perspective as you are working in data analysis in your area or in your field. Because if I'm working in another field, accuracy is totally different. So what do you think from your perspective, from your work, from your problem, real work problem that you came across that, okay, 80% is good enough for us? So I'll be taking your question. For the first question where you said, how can we tell if the future is good for prediction? Again, all our problems are based on data, and most likely there are real-life experts within this data. I'll just jump ahead because we were actually worked on a project where we dealt with a dental problem. So for us, we're data scientists or computer scientists. We don't understand really if a feature is good, unless it's a straightforward feature or something that anyone can probably inference from data. But when it comes to things like engineering problems or problems in the oil and gas field, most likely we would need a real-life expert to try and actually tell us whether this feature is really meaningful in the context of this problem or not. Because sometimes in machine learning, a model, because a model is not perfect, it might say that this feature is actually really affecting the target, but that's just something that's relevant within that data set. It's not actually relevant in the context of a real life problem or like in the general day-to-day lives or from what they've seen. Because we've worked with people who've been working for 30 years might be like, oh, this great feature, I can see that's, it's really affecting the model. And I'd be like, doesn't make sense, even though that, we're really into AI and, AI is very amazing, it's able to predict so many things, we can't, forget about the people who actually who are the experts in this field. Although there are, I think, algorithms that help you see which features are affecting the model, you can take, I would say that this is good, but I would take it with a grain of salt. Because if it's a problem that's medical, I can't say for sure that this is a true and valuable feature unless we get some insight or advice from people who are experts in this field. As I'm working in medical diagnosis, this is true when you are working with a human data. Or let's say we have an obvious features that call it that this is hypertension for the patients, and you have a very clear comment of CSV file with all the information. But when you come for images like the X-rays and MRI, you are not seeing real data. It's something, not something that you need the doctor to check out these images and check if it's feasible to be trained, good quality enough to diagnose this. This is the only thing that you can get from them. But as you said, if you have a CSV file that has a medical record for a person, like let's say strokes, and you have the history of that person, you can train that model on these numerical data. And you can have the doctor to say, this is good, we don't rely on blood type to diagnose this kind of disease. Like when it comes for images, it's just an image. Just one side to say he has this problem or that tumor and things on. So it's more a specific domain problems, especially when you come for medical diagnosis, because you have life. You have to be careful about it. Actually, good point as well. And I just want to comment also when you say which features, let's say now the use of AI is, as you say, more. So if you're using CNN or what they call it, the black box, you cannot say which features were used. And we got this question a lot from actors. So when we have the model ready, they will say, okay, what did the model decide on? Did it decide on the redness of the gum? Or as we will explain. However, this in our eyes, that's what we're using AI, because our eyes cannot decide. We'll see features, as you said, and extract from the images, features we cannot see with our plain eyes. However, it can be verified using, after some testing data, we will take it into production or testing phase with, let's say, the hospital, as for the COVID-19 project that we're going to talk about. We test it in the hospital, and then they will have patients, and our model, they will record the cough there, and have patients, and then take the PCR, COVID, and they will compare. And we will have, the score of this model. And that knowledge. Yeah. So what you are saying, that you are using some sort of validation to validate that your model is good enough for this kind of a problem. And this is one of the things that we do with the doctors in hospitals to convey that AI is good enough to help you, not to take over your job, but to help you and accelerate the time of diagnosis. There is another part of research that is the explainable AI. That is really a hard topic, exactly in the medical field. They are trying to reveal black box. We all know that in the models it's a very black box. You fit and you take it out. But the machine learning, before, we know the features. And when we did the feature engineering, we know what we are eliminating. That not contribute to the model. But with it, why we choose this one. So there is also, I like the idea of the, let's say, on-place validation. That this is our result, and this is our result. So this is one kind of solutions to have an AI acceptance in the medical field. And I would love to hear about COVID experience. Thank you so much. Now, does anyone have any question? Any question, please? Okay. So I'll be now. We're going to have
You can see in the notebook also there is a section for the model deployment. I have listed the AWS way of deploying your model. You can follow it on your own, as it will take much time and will need a specific account and whatnot. So it is there, you can use it. And for now, we're going to have a 5 minutes break, and we'll go back, inshallah, to the two machine learning projects in the
Hello again, this is Dimad Harith, and I hope you've all had a nice and brief break. Now we're going to discuss AI-powered machine learning, or AI-powered medical diagnosis. So the first project I'm going to discuss is the COVID-19 remote testing system. This is a project that we've been honored to work on after graduating back in 2020. It's a project that was supported by the Saudi Center for Disease Prevention and Control, as well as the Ministry of Health and CAPS. So this is a very high-profile project that we were honored to work on, and it was part of the fast response to the COVID-19 pandemic. So the first phase of this project was the data collection phase. As you may know, the pandemic was a very sudden, event. It happened suddenly, and of course there is no data to back up, this pandemic. There is no data online. So we had to create a data collection campaign, and as you can see, these are the posters that we created to motivate people to send in the sounds of their coughs, whether they were, COVID-19 positive or not. So we were trying to rely on both cough sounds and the clinical symptoms of these patients. And this is the website that we used to collect these cough samples. We also used the COFA data set and the Verify, and the good thing about these data sets is that they are medically labeled. So if a person were to submit their data to this data set, they would have to actually submit their PCR test onto the website. So we made sure that this data is valid. So we had 1,010 COVID-19 positive samples, and likewise we had the same number of non-COVID COVID-19 samples. So for the methodology, we all know the key symptoms of coronavirus. The clinical symptoms are the high temperature, the cough, and breathing difficulties. And then we also have the exposure risk. So these are things that would put you at high risk for being COVID-19 positive. So if you traveled to a high-risk area or you work in a healthcare facility, these are things that would make you more likely to have COVID-19. Both these clinical symptoms and exposure risks were used to create this form that is supported by the Ministry of Health, which is the visual triage form. So this form has many questions that will go through the exposure risks. So if you traveled abroad during the 14 days prior to symptom onset, etc., and the clinical signs and symptoms. So this is the form that we mainly relied on for the exposure risks. So for that, we have the rule-based system. So this rule-based system will try to go through that form that I showed you. Likewise, we have the deep learning approach, and this is the model that we use to train and test the coughs of the COVID-19 patients. So we have two sides to this system. We have the rule-based system to go through that form I showed you, and then we have this deep learning or machine learning model to listen to the cough and try to predict whether this person is COVID-19 positive or not. And based on that, we're going to give them a diagnosis. So before we begin, training our model, we have to look at the data. We used cough data, which is an audio. So of course, different audio files would have different audio properties, such as audio channels, sample rate, and bit depth. So this audio file might be stereo, and the other one might be mono. And this we can't use this data for machine learning just yet. We have to pre-process this data to make sure that it's all consistent and standardized, as you can see here. And then we have to go through the feature extraction phase from the samples to train the model. So we need to acquire a visual representation of this data. There are so many different forms of visual representations, such as time-domain waveforms, spectrograms, and null frequency substrate coefficients, also known as MFCC. And the last one is the most detailed and most commonly used one, and that's the one that we went with. So after getting the visual representation of this data through the MFCC visual representation, these features, or this image actually, can be translated into 39 numerical features, which, like I said in the first part of this workshop, machines can only understand the numbers 0, 0, and 1s, values, and whatsoever. And then we have the class label, either positive or negative. So this patient is COVID-19 positive or negative. So, like I said, the previous part, we split the data into training and testing. We use 75% split for training and 25% split for testing. And then we tested so many models. From them was DNN, which is the deep neural network, random forest, XGBoost, boost, naive bias, and logistic regression. And we validated all these models, and we found out that the best one, which I'll go through the results, is the DNN model. So for the DNN model, we got actually an accuracy of 90.6 when using the predicting or using the cough samples only. When we further supplemented this model with the clinical symptoms, demographic information, and the clinical assessments of the cough sounds from the form that I've shown you, we were able to actually bump up this accuracy up to 95.94%, which is a very good accuracy. So for deployment, we used Python and the Flask framework, and we deployed the model and the application on the Heroku platform. So as you can see, this is the web application that we deployed our model on. People can begin their tests online. They can also record their coughs and submit it for detection. And based on your cough and the clinical symptoms that you've entered, you could either be COVID-19 positive or negative. We've also published 2 research papers off of this project. One of them is entitled E-Triage System for COVID-19 Outbreak, and the other being the one for cough sound detection diagnosis using AI techniques. Alhamdulillah, it was a very, very rewarding project, and I'm thankful that we have the opportunity to share this with you. Moving on, Haj is going to present the second AI project.
Okay, so as you saw in Dima's part, when she talked about the COVID-19 project, it was audio files, okay? In this project, which is a Predict, it was a collaboration between the preventative dental department in the College of Dentistry in our university, Imam Abdul University, and the Computer Science department. This is an automated system for the early diagnosis of periodontal disease. So what is periodontitis? It is a serious infection of the gums and the supporting structure of the teeth. And we need to understand, before we work on any problem, how does it occur, or the features that we're looking for, as we mentioned or discussed before this session. So according to the World Health Organization, periodontitis is the 11th most common disease globally, and it affects 20 to 50% of the global population. So it is, a global disease that needs to be, or let's say, use computer to aid in the diagnosis of this disease. So why did we, propose with the help of the experts Predict to replace the invasive and painful way of the diagnosis as they use probes? It will reduce the chances of any bacterial infections to the unhygienic dental probing environments. It will also be a cost-effective, as it will eliminate or reduce the clinical examination and prevents the patients from undergoing, the costly procedures in the advanced stages, as it will aid in the early diagnosis of periodontitis. Okay, so we got our data set from the College of Dentistry, and we're going to explore it together here. So we have a total of 47 patients. These patients are both male and female. We have, for each patient, the images that were taken into a different point of time, one before their orthodontic treatment, one a week after, and 1 week or 4 weeks after. So we got a total of 141 images and was supported by clinical findings, which is the experts, annotations of the gum. So this will be explained more in the next slide. So after we did cleaning, we dropped 7 images as they were duplicated or had incorrect clinical scores, and we split data into 80% for training and 20% for testing. Now, I'm going to talk about the clinical data that we got support the images that we had, which is the gingival index. The gingival index is the measure of how inflamed this gum, this gum of the patient is. Normal is 0, 1 is mild, moderate, and severe. And as you can see here, we use 1 Hz encoding to make more sense of that column. So what was the solution that we applied in this case? Okay, but first we need to understand that our focus was the big M, or what they call the frontal teeth, and we had the clinical measures here for the distal, mesial, and the mid. And as you can see here in the table below, we have, let's say, zeros and ones, which means the gingival index for each area of information. This was, annotated by doctors. Okay, so the approach or the solution for this problem was to develop two deep learning models. As you can see here in the first section, the first deep learning model is a faster RCNN that will be used to specify our region of interest or crop our region of interest, which is the big M. The next faster RCNN model is used to specify or look for the information part in the cropped image. And we're going to talk in depth about these models. Okay, so the teeth detection model and the cropping algorithm. This was all in the pre-processing part. So the teeth detection model, we used a tool to first annotate the images. So we will train the deep learning model or the faster RCNN model. We need to give it data. The data will be the coordinates of the teeth. So why the teeth? We are looking to get the big M. So a way that we develop is to first look at the prominent feature here, which is the teeth, and we have, as we can see here, the tractors, the wooden stick, which is a noise to the data, a noise to the image. So we need to remove it. So we train the model to identify the teeth. We get the XML file, and we use the TensorFlow object detection API, and we input the model with the TFR records and with the ResNet 50 classifier. And the output was, let's say, the drawing box, which has the coordinates of the where the teeth is. And we also customize this visualization as I will explain in the topic. As you can see, the performance is good, and it is very good because the teeth is a prominent feature in that image. As you can see here, the teeth here is a prominent feature. So for the cropping algorithm, as we got the coordinates of the box around the teeth, we developed a specific mathematical algorithm that will look or double that box above and then get the coordinates exactly to get them. And this algorithm successfully cropped all the images or the big M's from all the data that we have. Now, for the information detection model, we have two parts: the image annotation, which was with the help of the clinical data from the doctors, and we had the model construction, which we split the data into training and testing, optimize the training parameters of the CNN model, and we train the model with the cropped image. Now, for the performance measures, we scored an accuracy of 77%, and a mean average precision, which is used for the object detection, which is an object detection matrix of 68%. And as you can see here, the current study at the time had scored 66%, so we scored 10% higher. And this goes back to the question before: how can we, measure if this was a good accuracy or not? As you can see here, we relied on, let's say, the state of the art of that model. And as you can see here, our detection and the clinical findings exactly, as you can see here, most of it were correctly identified, and we have, missed only two. So this is all for one patient. Now, for the deployment, we use the same method, the Flask framework and Python to deploy the model to Hero. And this is just, a glimpse of our application. As you can see here, you can upload the image and you can see where the frame part you know.
So please, if you have any questions, we would be happy to receive them. Hi everyone, I'm Rafa Ghamdi, and firstly I want to thank you for sharing these amazing projects with us. My question is about the first project. How did you convert the domain form for help sound to mil frequency form? You're asking about if the audio files were converted exactly into MFCC data. We first converted the audio files into images, okay, of the waves. Can you go back, And then after that, we got the MFCC values from the images, and from the digitized images. Does that answer your question? Actually, I didn't mean that. Did you see the first picture for time domain waveforms? Yeah, how did you convert it to mil frequency? There's a Python, library or an algorithm for it can use it to convert.
This goes into like audio engineering. There's like a mathematical equation or audio engineering. It's more of an audio engineering art rather than computer science, I'm guessing, but there is a library to convert it. And usually when you tackle a problem that you're not very familiar with, you usually go with the methodology that is usually used. And as per the literature review, MFCC was the best representation of this data, so that's what we went with. But it's mathematical equation. And again, I'm not a mathematician. As computer scientists, we usually look into what's the best in the industry.
Any more questions, please? Thank you again. I think we figured out asking a lot of questions. If you go back to the result for the accuracy, so again, business accuracy is reaching I think 12.
Yes.
Is acceptable in the medical field in your specific problem. Okay, as our data is actually was on 47 patients only, and we used so we cannot say this is a good accuracy. However, it is better was on what was the state of the art. And if we want to generalize it, we cannot say this model can predict bronchitis and we're using only 47 patients. However, it can on these data sets or on this this group.
For them, it was acceptable. For them, it was acceptable, and they were very happy with the results because this is the first time that a problem of this type has been tackled in their field, especially using their own specific technique, which is the one that focus on big M. But for them, an algorithm that's first of its kind, this was very good, especially since in the previous studies, we did a literature review, and all previous studies. The only ones that scored a good score were the ones that were using actual measurements. So they were classic regression problems or classification problems. So this is the first, or I'm saying, one of the first problems where we tackle, it's an image classification problem that's focusing on big M. So for them, it was acceptable. But again, we looked at the problem that was most similar to our problems from this study. They used a different approach and they got an accuracy of 66. And for us, we achieved an accuracy of 77. This isn't the best, but as computer scientists, we always we consider this a publishable result because we built on the previous result, and we believe that people who come after us can build upon this result even further. But inshallah, we did publish the publishing paper in the International Journal of Environmental and Public Health. We're hoping that this let's say we left a thumbprint or fingerprint, in the medical field that people can look back to and build upon the future. Yeah, so what is the number of samples that you have treated? Because we don't see it in that training. So we need more data. We trained 141 images and training. Yeah. No. So you have that rely on 100? Yes, 141. You get this result.
Yes. Well, I believe we wanted to get more data, but considering that we did our project during the COVID-19 pandemic, خلاص everything's sort of shut down.
Sorry, that's a bit obvious, right? This project again. Sorry, I have no idea what the topic is again. Is this research part of the college here, or is it part of the university?
No, it's part of IAU University.
IAU, right?
Yes.
Okay, so sorry, who's the advisor? Supervisor?
Dr. Nita, and you were the reviewer. Yes.
Okay, because I'm like, I've seen this topic before.
Yes.
It's been a while.
Yeah, you're right. No, you're right.
Okay. أول شيء طبعا congratulations ما شاء الله you managed to publish. Again, as a recap, this is موضوع numbers for somebody who also comes from the medical field. I'm not a doctor, but I work with doctors. The simple answer is no. لأن هي المشكلة إنه when you're dealing with medical AI, it's really difficult to develop وتطور مثلا models وهي البرمجيات هذه اللي هي تستخدم فعليا في الميدان بالذات في مجال الطب حساس جدا. تحتاج إلى أنظمة فعلا ممكن تعتمد عليها لأنه قرارات فيها طبعا سلامة المرضى وهكذا. It's very risky. بس sample size. يعني أنتوا أخذتوها فقط حصريا من مستشفى الجامعة أو كيف فينكم توجهوا بعدها؟ مستشفى الجامعة. ما شفتوا بيانات شبيهة مثلا في مستشفى ثاني؟
Yeah, because the data was not just images, but they had to be professionally annotated and labeled. It takes some effort to do all this. We had to rely on the data that was provided to us.
And the research was focusing on the big M. Exactly. Yeah. So that was, the approach that they wanted to prove that if we use the big M, are we gonna, predict if there is a bronchitis or not?
في أي توجهات مستقبلية للمشروع؟ الريسيرش بصراحة it's very
This was proposed by Professor Kasumi. So this was her idea that we will look for the inflammation in the big end. So this was not done before in the research.
Yeah, we published the research. Their intention with this project, like you said, in the medical field, we can't really rely on this 100%. But back in the day when we actually developed this project, it was more of like initial diagnosis. So if it does predict that your gums are inflamed, then that's a sign that you should check this out. We were targeting people in more rural areas where they can't go to the dentist as often. But this is a good first step for them to.
Yeah, and we were targeting to get more data, but
COVID happened, of course.
كل ما you've reached this stage ما شاء الله again تحية كبيرة صراحة. I'm remember even when I read your documents. This is one of the very best and unique projects I ever came across. ما شاء الله again بعد عن respect جزاكم الله خير فعلا شرف الله صراحة.
Again, any question, please? More questions?
So we want to acknowledge, the professors, doctors, our teammates, Yasmin, Rudan, and Hamdi, who have helped us, and to get these projects published in production, and that's it. Thanks to them.
And thank you to Dr.
Thanks
Mustafa.
to Dr. Mustafa.
She couldn't have done it without you. Thank you. That's it. Thank you all who have attended either physically
or online, please don't forget to scan the QR code on the screen to make sure you are, that you're registered or that you've got the certificate at the end of the workshop. Thank you all, and thank you again for joining us.